Don't forget to subscribe and ring that bell.
All right, all right, all right. The 2022 Calculus examination free response question number 2, en español número 2, de italiano 2. But no matter how you say it, we are going to do free response question number 2. And yeah, man, cool, man. We get a graphing calculator. Great. If you're in the market for one, I say this every time. I put links in the description below. I personally use the TI-84 Plus CE, the color edition. I love it. They have a whole slew of cool colors. Yes, I have a class set that my students use, and yes, my personal one is the sweet, sweet mint green one. I love it. Let's get started and let's bang this out. Let's go. Number 2 says, let f and g be the functions defined by f of x equals ln of x plus 3 and g of x equaling x to the fourth plus 2x cubed. The graphs of f and g are shown beautifully in the figure above, and they intersect at 2 points where x equals -2 and at some other value where x equals b. We don't know what b is, but we know that b is greater than 0. Okay, so find the area of the region enclosed by the graphs of f and g. Okay, so the first thing, let's stay with purple. Area of the region enclosed. So if I'm looking for this area between the curves, okay, you should know that the area between the curves is the integration of the top curve, or the bigger curve, minus the bottom, or the smaller curve. All right, and it looks like we have a couple of pieces of information. My lower bound is at x equals -2. That's where they intersect on the left. My upper bound, I don't know yet. I don't know this point yet. So they're just calling it b. Okay, so I'm going to come down here and I'm going to do b. So there's a couple things I need to identify. Number one, which is the top curve and which is the bottom curve? The top curve is this one. I'm going to tell you right now, that's the ln of x plus 3. And the bottom curve is this one. I'm going to tell you right now, that ends up being x to the fourth plus 2x cubed. Okay, so if you're going to say, well, how would I know which one's which? I mean, we have a graphing calculator. We're about to put them in because we need to figure out what this b value is anyways, that upper bound. So let's grab the handy-dandy calculator. And again, even if you didn't know which graph was which, all right, we're going to put them in. And you could tell by that point. Let's go to y equals. And we got the ln of x plus 3. Okay, that's going to be my blue graph, just like I have with the blue line. And the red graph is going to be x to the fourth plus 2x cubed. Now, if I look at my window here, my graph, it really doesn't go higher or lower than 1 on the y-axis. So I'm going to go to maybe 2. And on the x-axis, it goes from -2 and some value between 0 and 1. So I want to try and make my window somewhat similar. So on the x, let's go from -2 to 2. Actually, let's go from -3, so we see the -2. It's a 1, that's fine. 1. And the y is what I want to go -2 to 2. So if I graph this, outline is the first one. There's outline. That's my blue one that's coming up and over. All right? And my x to the fourth is in red. You see there it is. So I now know that the outline, the natural log function, is my top one. And I also know a couple of things. This right here, this point on the left where they intersect is -2. I need to figure out this point here. That's my b value. That's what I got to figure out. And I'm going to use the intersect function to find that. Second trace, I'm going to pick 5 for intersect. And I got to move my little spider dude closer to that intersection point. And when I get close enough, it doesn't have to be right on it. It can just be close. I'm going to hit enter 3 times. And if I look at the bottom left, the intersection x value right here, we'll call that 0.782 because we'll round that one up, okay? 0.782. 0.782. 0.782. And my top curve is the natural log of x plus 3 minus, okay, that lower function, which is x to the fourth plus 2x cubed. Don't forget your dummy variable. And you need parentheses here because you are subtracting the whole function. Let's put that in the calculator and hit enter. And we are going to be good to go. Math 9 from -2 to 0.782. And the first function, or the bigger one, the ln of x plus 3, minus, in parentheses, the smaller function, x to the fourth plus 2x cubed. I'm going to close that parenthesis and not forget my dummy variable. There it is in all of its glory. And if I do that, the calculator gives me the answer, 3.60. Let's make that a 4. Let's round that up to a 4 because the number after it is 5 or bigger, shall we? Approximately 3.604. That was an easy one. As long as you knew that the area between the curves is the top curve minus the bottom curve, and you just knew how to use that intersect function for the upper bound. All right? All right, 2b. For an x value between -2 and the b value, which we now know, okay, is 0.782. When x is between those inclusively, meaning it could equal them as well, let h of x be the vertical distance between the graphs of f and g. Okay, so let's take a look. The vertical distance between f, okay, and g. All right, so f of x is the top curve. G of x is that bottom curve. All right. And then it says, is h increasing or decreasing when x is -0.5? Give a reason for your answer. Well, anytime I think increasing or decreasing, I think derivative, right? So let's just establish h of x. Okay, I want to find the derivative of that because they're asking me, is h increasing or decreasing? Okay, well, what is h? It's the difference. Okay, it's f of x minus g of x. Okay, it's the difference between the two. All right, so I'm going to say it's f of x minus g of x. That's my function, that vertical distance. It's the top graph minus the bottom one. Okay, now increasing or decreasing means I'm going to look at the derivative. If the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. It's that simple. Look it. Don't sit here and try and take the derivative of the ln of x plus 3 and the ln of x to the fourth plus 2x cubed by hand algebraically and do all this hard work. You get a calculator. Okay, there'll be time to do hard work. Don't worry. Right now, not so much. The derivative of f is just f prime of x minus the derivative of g is g prime of x, okay? And I want this at an x value of -0.5. So basically, all I'm doing, okay, is I'm plugging -0.5 into my derivative here, which means I take the derivative of f at -0.5 and subtract the derivative of g at -0.5. Use your calculator to find these derivatives. Find this one, then subtract, finding this one. That's it. It's great. So let's go here. And again, we're going to use our calculator. I'm going to go to Math 8. I'm going to take the derivative of the ln of x plus 3 when x is -0.5. There you go. Let's call that 0.4. Okay? And now I want to do the same thing, Math 8. I'm going to take the derivative of x to the fourth plus 2 x cubed. Now, these are very simple functions to take the derivative of, but when we get the calculator, just use the calculator. Okay, and I want that derivative at negative 0.5 as well. And there you go. So what I'm going to do is I'm just going to subtract those. I'm going to take this minus the 1. I'm going to take those two answers and subtract them. And I should get negative, but we'll round that to negative 0.600. Okay, so right here, this tells me, oh, wow, that's a z instead of an equal sign. This tells me right here how I'm getting my answer, negative 0.6. Okay, but they're not asking you what the value is. They're asking you, is it increasing or decreasing? And I'm going to answer that right here. It's decreasing. Give a reason. Since h prime of negative 0.5 is less than 0, meaning it's negative. That was very, very simple. That would have been simple to do. Well, to come up with that 0.4 with natural log might have been a little difficult. But you could have done this by hand. You know what I mean? But we have the calculator. Use it. On to 2C. The region enclosed by the graphs of f and g is the base of a solid. The cross sections of the solid taken perpendicular to the x-axis are squares. Find the volume of the solid. I love doing these. I'm sorry, but I love it. Here's f of x. Okay. Here's g of x. We've done this so many times at this point. G of x. Okay, and they intersect at negative 2 and 0.782. So they're saying the cross section are squares. So if I go here to here, it's a square. Okay, that's a square. And I have all these squares. How do I find volume? A rule of thumb is volume is what I get when I integrate area. Okay, so the question is the area of a square. And it's not really a question. Is I take the side and I square it. Okay, so I take my side squared and I integrate it. I integrate my side squared. The question is, what is the side? Let's look back up here. You see how I drew this square? This distance from here to here is the side. The difference between f of x and g of x is the side. All right, so my side is f of x minus g of x. So if that's my side, I'm still going to have to square it. Do not forget the squaring. So I'm going to integrate. My bounds are from negative 2 to 0.782. My side, which is f of x minus g of x, that whole thing squared, dx. That is it. I am integrating the area. Let's use our calculator. God, I love that they give us a calculator for these things. So I'm going to go back to math 9. And again, from negative 2 to 0.782. Now, I want to make sure that I put parentheses because I'm going to square this whole side. So I want to put the f of x minus g of x in its own parentheses. So it's the ln of x plus 3, close that parenthesis, minus, open another parenthesis for my g of x, which is x to the 4th, plus 2x cubed, close a parenthesis for g of x. Now I need to close a parenthesis one more time for my whole side. What do I mean? Okay, so this parenthesis and this parenthesis match, okay? This parenthesis and this parenthesis is for the f of x. But now, just like I opened a parenthesis here for the whole side, I need to close one here so I can square it. All right? So I am going to close a parenthesis and square it. That's always something that people forget to do, just like they forget the dummy variable. And if I did that right, the calculator is going to tell me that my answer is 5.340. And that exactly is the answer 5.340. That is the volume. If I had a bunch of shapes that were squares between f of x and g of x, boom, done. Here we go, 2D, and this is the last problem. And this is a tough one. When I first read it, I was thrown off a little bit, and my students really were. And so I really analyzed the situation and looked at it, and then the light bulb went off and it became easy. So let me explain it to you as I was explaining it to my students, and hopefully you get it, okay? When it comes to volume and, finding changing of rates of areas and volumes, we typically only do it one of two ways in calculus, all right? So we either do between two curves, and we get a shape, like in this case, it's a square between our curves. Okay, so I can find the volume of that shape if the base of the distance between them is a side of a square. So I could just take the volume of that. I just integrate the area of the square. That's one way we do volume. The other way is related rates. The other way is related rates, and that's a really weird A. So the difference between the two is, for this one here, okay, between the curves, I'm just integrating from my bounds from A to B. If I want volume, I'm really integrating area, and that's it. Okay, but for related rates, okay, there's something along the lines of, and again, it's the change of rate of volume, where this one is actually finding the volume, okay? So I can take volume, all right? I can take the derivative of it. Let's say it's, screw this, we'll do area. Pi r squared is the area of a circle. I would take the derivative, it would be 2 pi r squared. But then I got to multiply by the derivative of the radius. The related rate is what I got to multiply by. Okay? Now, if I were to take the derivative of something like this in the calculator, it would just give me this. So when I do related rates, I actually have to make sure I multiply by the rate of the variable we're using. In this case, in my example, it's r for radius. Okay? This problem D combines both of these, meaning it gives us a shape between the curves, okay? And it talks about volume, or in this case, area, and we're used to doing it, one way, but we're not used to seeing a related rates problem with a shape between two curves. And that's exactly what we're doing here, okay? So you've got to understand that first. Let me read 2D. It says a vertical line in the XY plane travels from left to right along the base of the solid described in part C. Okay, the base of my solid is this right here. That vertical line, we'll call that side. It's the side of my square. It's going to move left to right this way. So it'll get smaller, smaller, smaller. Okay, and kind of get smaller and smaller. All right, it's moving that way, but it also tells me that my side is moving, that rate is moving at a constant 7 units per second. So let's call this S prime. That's 7. That's going to be, instead of R, okay, that's going to be S prime. So I'm going to have to do what? Find the rate of change of the area of the cross section. Okay, it's the same thing for part C. It's a square. Above the vertical line with respect to time, when the vertical line, okay, our vertical line is S, when that vertical line is at position, x is negative 0.5. All right? So what do I have? I have a square. The area of a square is just side squared. If I need to find the rate of change of that area, A prime, it's going to be 2 times S. Okay? But again, I've got to multiply it times S prime, which is 7. Okay? In the calculator, it'll do this part. If I have a value for S, and it'll give me a number, but I also got to end up multiplying it times the 7, the constant rate, the related rate. All right? So here we go. The $1,000,000 question is, what is my S? What do I put in for S? Well, I don't know. It's the difference between my top function minus my lower function. So I could write this one of two ways. And we get a calculator, thank God. So S is really f of x minus g of x. Or in this case, it's the natural log of x plus 3 minus x to the fourth plus 2x cubed. That's the side. Don't forget, I need to square the side. All right? So the area, okay, I'm going to cross out this little s. Well, area is side squared, which means I need to square this whole thing. That is the function that represents the area of my square. That's what I want to take the derivative of. So on a prime, when my x value, negative 0.5, that's going to give me this part. But I still got to multiply it times 7, that constant rate, times 7. Okay, so in my calculator, I'm going to get this number, this derivative here, when x is negative 0.5, and then I got to multiply that times 7. All right, so now that we know what we're doing, it seems rather simple. But this whole explanation and the fact that I've never done a related rates problem between two curves in a situation like this on an AP exam, that's what throws me off. It's like, wait, we haven't done this before. You know, it's not normal, but we can do it, especially with the calculator. Oh, my Lord, let's get rid of these. Let's go to Math 8. I'm going to take the derivative of the side squared. It's the ln of x plus 3 minus x to the fourth plus 2x cubed. That whole thing is squared, okay, because it's a side squared. This is the equation of the area. I want that at negative 0.5 for my x value. There you go. Okay? Negative 1.3245, whatever. Let's call that negative 1.325. This right here, let's do a pen, is negative 1.325, but I still need to multiply it times 7. Okay, because that's the related rate. That's this thing right here. Okay, so I'm going to go back right here, times 7, and it is negative 9.272. All right, negative 9.272. And you might say to yourself, wait a second, I don't know, the related rate was a positive 7. How do I get a negative number? Let's look up here. As this blue line, I'm going to erase all this. As that blue line goes from left to right, okay, won't the blue line get smaller and smaller? It should. Smaller and smaller, and it'll get smaller. So yeah, the area should be getting smaller. That should be a negative rate. And there we go. Negative 9.7, or yeah, I'll be okay. Negative 9.272. The work didn't take a lot at all. Understanding the problem, because my students kind of struggled with this. Okay, understanding the problem, hopefully after hearing the explanation redundantly and repetitively, you now get it. All right, we'll see you.
Don't forget to subscribe and ring that bell.